Okay, 4-2. Forget this because we didn't cover this yet. Exponential functions are, we just did them, a to the b x, where if b is greater than 0, it grows. If b is less than 1, it decays. Okay, keep that in mind. Grows or decays. So when you're talking about money or bacteria and stuff like that, usually you do start with a positive number. Okay, so this NO represents A. This 1 plus R represents B. So you always have a 1 factor. Okay, it's either bigger than 1 or less than 1. So your rate, if you look over here, N is called your final amount. Usually this is what you're solving for. A is what you're starting with. So initial amount means whatever you start with. NO. Okay, rate of growth or decay. If they say it is a sale, for example, 30% off discount, that's a decay. And you would do subtract 30. So for example, if you have a 30% rate of inflation, sometimes you hear those words, this would be NO, this is your starting amount, 1 plus 0.30 T. So in other words, you would add these together and get 1.3. 1.3. Because that's greater than 1, this is going to go up. It'll be a growth problem. But if you had a 30% discount or a sale, it would be NO 1 minus 0.30, which is the same thing as saying NO 0.7. Do you see now how that 0.7 became less than 1? That means you're going to have a decay. Okay, it's going to be a discount. Your money's going to be off. Whatever. So it's 30% off the original amount. Means that you're paying 70% of the actual price. 30% off means you're paying 70% of the price. So you're going to be looking for this 1 plus R. So R is called the rate of growth or decay. T is time, but 1 plus R is called the growth factor. Together, added to 1, is that bigger than 1 or is it less than 1? The growth factor. Are you going up? Or are you coming down? That's basically what you're doing. So in terms of money, A is the final amount in your money. P, so like let's say you had a graduation party and you got $2,000 and you're going to go put it in a bank and your bank pays 3%, 4% interest. So that's like 0.04 and it's compounded monthly. So N means 12. See that right there? Number of times compounded per year. So if it says monthly, that'd be 12. And then you write it again, and T is number of years. So let's say you want to keep it in there for 10 years. That's how you would write the problem. Okay, this is just an example. So suppose that a researcher estimates that the initial population of colony cells is 100. So 100 is the starting amount. So you can call it NO, starting amount. If the cells reproduce at a rate of 25% per week, they reproduce, that means they're growing, right? 25%, so you're going to be adding 0.25 to the 1. So R is 0.25. What is the expected population of the colony in 6 weeks? So T is 6 weeks. Okay, so the time can be in days, weeks, hours, years, whatever you want it to be. So in this problem, N is what we're solving for. NO is 100. 1 is always in our formula. See the 1 right there? Always in your formula. The rate of growth is 25%, and you're going to do 6 weeks. So it's 100 times 1.25. You see how that's bigger than 1? So this should be growing. And you just punch it in your calculator. It's pretty simple. So you have 100 times 1.25 raised to the 6th. Oops, I think I forgot a parenthesis here. It's kind of important. I'll put a left parenthesis right there. 381, and we're going to go 0.47. 381.47. Now this was not money, right? This was cells reproducing. What is expected population of cells in 6 weeks? 381.47 cells are expected in 6 weeks. Determine the amount of money in a money market account that provides an annual rate of 6.3. So R is 6.3%, but as a decimal, that is 0.063. It does say it's compounded quarterly. Quarterly means that your money compounds 4 times a year, so that means N is 4. 1,700 is invested, so P is 1,700. And your time is 8 years. So how much money is going to be in the account after these 8 years? So here we go. So here's our formula. P is your initial amount, 1,700. 1 plus your interest is got to be written as a decimal, so move it 2 to the left. Compounded quarterly means divide that by 4. Now quarterly means 4 times the 8 years. So in other words, this 4 times 8 is 32. That's what you should be punching in for your exponent. It means your money compounds 32 times in 8 years. So you just punch it in your calculator, 1,700 times 1 plus 0.063. Oops, I forgot to divide by 4. Let me get rid of this. Divided by 4, then a parenthesis, raised to the 32nd power. So that's what it looks like. Bam. So $2,803.03. That's how much money will be in your account after 8 years, like that. You made $1,100 for doing literally nothing. Will it be more or less if compounded monthly? Well, let's look. Everything's the same except monthly means 12. 12 times 8 is 96. Now your money is going to be compounded 96 times. So if I was doing this, I'd press second enter. I'd change this to 96, first of all. And I'd change the 4 to a 12. Second insert 2. So it looks like everything else is the same. And press enter. So it looks like it's going to be less. I mean, this is more. 28.10, 35 cents. Will it be more or less if compounded monthly? You'll have more. About $7.22 more. What is the quarterly interest rate for an account with a nominal rate of 5% compounded quarterly? So you take the 5% and then divide it by 4 because it's quarterly. So your nominal rate is 0.0125, which is like 1.25%. Move the decimal over 2, it's 1.25%. So quarterly interest rate for an account with a nominal rate, if the nominal rate is 5% compounded quarterly, the quarterly interest is only going to be 1.25. Just divide by 4. Divide this by whatever this is. 5% divided by 4. That's what nominal rate is. And that's it for 4.2.